Imagine you are walking down a busy street. You pull out your phone and you quickly say, "Add eggs and milk to my shopping list." If you said that to a friend, they would understand you instantly. As humans, we naturally process messy speech, background noise, and casual phrasing without a second thought. Computers, on the other hand, require data to be sorted into clear rows, columns, and hierarchies. They rely on strict organization to function. When you speak into your phone, the processor doesn't hear a grocery order. It receives a stream of unstructured text, data that lacks the organization the computer needs to take action. You and your phone speak in formats that don't naturally fit together. To bridge that gap, we need a translator. That translator is natural language processing, or NLP. It sits right in the middle between unstructured human speech and structured computer data. Filtering unstructured speech into structured data is natural language understanding. Reversing this, forming conversational responses from organized data, is natural language generation. Today, we are going to focus entirely on that first step, how machines take our messy input and actually build understanding. NLP isn't just one algorithm, it's more like a bag of tools. Every sentence is processed through these tools, refined and categorized one by one. Let's apply this bag of tools to our "add eggs and milk to my shopping list" command and see how it works. First, tokenization chops the sentence into 8 individual word blocks. Next, stemming finds a word's base by removing endings, slicing words like running or runs to leave just the core concept, run. But stemming can mistakenly collapse both universal and university into universe, changing the meaning. For trickier words, lemmatization looks at the dictionary meaning, identifying that the true root of better is good. By cleaning up the text, the computer reduces thousands of human word variations down to a small set of basic data points it can track. Identifying single words still isn't enough to understand a sentence. The computer also has to map out the grammatical structure using part-of-speech tagging. Take the word make. In "I am going to make dinner," the tool tags it as an action, but in "What make is your laptop?" it tags it as a noun. The computer looks at surrounding words to determine the context. Next is named entity recognition, scanning text to identify specific proper nouns. It flags a word like Arizona with a location pin icon and marks Ralph with a human profile icon. Look at the output of our shopping list command now. The raw text has been transformed into a strict hierarchy. The computer sees a clear shopping list category containing the items eggs and milk. By running through these specialized tools, chaotic human speech becomes a set of instructions the computer can actually follow. This process of turning unstructured text into organized data powers the digital services that you use every single day. When you type a question to a chatbot, it uses NLP to figure out what you are asking. From there, it follows a branching path of if this, then that logic, like a map of choices, to find the right answer. Your email provider relies on NLP for spam detection. The tools scan incoming messages for structural red flags, like poor grammar or an artificial sense of urgency, to filter out junk mail. Algorithms also use sentiment analysis. This allows them to read thousands of written product reviews and determine if the tone is positive, negative, or even sarcastic. And NLP is essential for machine translation. Without analyzing context, "the spirit is willing but the flesh is weak" translates literally as "the vodka is good but the meat is rotten." By giving computers a way to untangle our grammar and intent, natural language processing translates the messy creativity of our speech into the structured logic needed to power our world.